Welcome, my name is Iain Gillot from IGR, and we're here today with Durga Malladi from Qualcomm, here to talk about 5G. And so, Durga, let's just dive straight in there. A lot of discussion out there about 5G. Where are we with the commercialization or the standardization process, and how does that lead into commercialization?
So, as far as the standardization is concerned, we are approximately at the halfway point between. It's been about 9 months since the standards formally started being written down in specifications. And the first phase of 5G, which is based upon what's known as a non-standalone mode, wherein you rely upon a 4G anchor, that phase is coming to a conclusion fairly quickly. And then we got another 6 to 9 months left in terms of the full-blown standalone mode specifications, which includes the core network as well. So we're approximately halfway there. But it does actually lead towards where we are going with commercialization in 2019. I think it's an important milestone that we're achieving in this halfway point with non-standalone mode specifications.
Right. So you do expect some commercial networks towards the end of 19, is that?
We would say, no, actually we would say in 2019,
okay.
Potentially even in the first half, but definitely in 2019.
Right. So Qualcomm's been a big proponent of using the mmWave. And there's been a lot of discussion with that for fixed wireless access applications, but you've talked about it as well for for mobile applications. So you want to talk a little bit how that works, because obviously there's some drawbacks there, but what you've been doing, I think you've been doing some trials. So.
That's correct. So first of all, it's only been recently that we've been talking a lot more about mmWave for mobile applications, as we're getting more confident in the way things have panned out as a part of our testing process. So we were quite skeptical about it, and we really wanted to make sure that this is a technology that if it's ready for prime time, then it better work in a handheld form factor where there are a lot of constraints that come into play that you usually don't see in fixed wireless backhaul. Smartphones and tablets, you hold them in different configurations, you have blocking with your hands, blocking with your head and other bodies, etc. And so we did a lot of tests to see what are the techniques that are needed to make sure that mmWave works properly in a mobile handset. Power consumption is important. That's a very important driver for us. As we go to gigabit speeds, we still want to make sure that you only charge your phone once every so often and not all the time. And so we spent some time on that from an RFIC technology standpoint. We also wanted to see exactly how do we fit a very large number of antennas in a handset. And the tests that we've been doing over the past 1 to 1.5 years in a mobile deployment, multiple base stations, in a minivan configuration, people holding the phones in their hands and driving around, it's been quite promising. We still have to do a lot more stress testing of it, but at the same time we feel quite comfortable, and that's why we are now quite happy to talk about the potential of mobile mmWave in handsets and the gigabit speeds that it can unleash.
So you mentioned some of the trials and testing you've been doing. Also, of course, 5G is based on, Release 15 is based on OFDMA, which we've had for a while now.
That's correct.
It's for LTE users. So what type of things are you testing for 5G ready for the commercial deployment? What sort of areas are specific?
Right. So I'll speak about both the below 6 gigahertz, sub 6 gigahertz, and in mmWave. So let's start with sub 6 gigahertz. The tests that we are doing right now, including the one that we showcased with one of our infra partners, ZTE, in the China Mobile event, that was a full-blown spec-compliant implementation of the physical layer. That was a downlink demonstration, but a full-blown spec-compliant implementation, which showcased how you can use the state-of-the-art channel codes, LDPC codes, for data communication in 5G. And that was like a way of simply testing the fact that does it work properly. Now, of course, this is still a very preliminary test because it's in a confined environment. We still want to do large-scale field tests with this, but that's the starting point of it. What we intend on doing is looking at both the coverage and capacity of a full-blown 5G system in a field trial. What that really means is that if you were to just take a look at the peak data rate, now the data rate that we showed, 1.4 gigabits per second, it's pretty good, except that it's not like a order of magnitude difference between that and gigabit LTE today.
Right.
5G NR in these mid bands, the 3.5 gigahertz band where we showed the demo, is more about increasing the capacity of a cell by utilizing concepts like multi-user MIMO in the right way, so that we don't we really get a cell capacity, and that's the reason why individual users, as an average user, gets a higher data rate. So it's really about the average user experience and the overall cell capacity. That's what we really want to test with that. But we've taken the first steps towards that in a spec compliant manner. On millimeter wave, it's a combination of cell capacity and the basic functionality and robustness of millimeter wave operation in a mobile environment. And it's that robustness which is more dear to heart for us right now on millimeter wave. We want to make sure that with the investment that's being made into this technology, it actually pans out the right way in 2019. So the idea of putting it in a handset, putting millimeter wave technology in a handset, doing these demos where we are doing non-line of sight communication. The testing that we did earlier this year, and we showcased it in Mobile World Congress Barcelona earlier this year, was one of those tests where we literally took this handset in a minivan and drove it around just in a regular way. This is in our test bed in New Jersey. We did handovers between multiple access points. We did these tests outdoors and indoors, completely non-line of sight environment, picking up reflections from multiple areas. That's the kind of a test now we want to do at scale. And that, by the way, was a very good indication for us that the basic functionality is pretty good. Now we have to build upon that and go into full-blown network level capacity analysis with field trials. Of course, another part of it is making sure that the power consumption in a device is small. So that's an area that we've been working on with our RFIC development. But so these are the two things which are essential beyond the standards, which are essential in these trials that we've been talking about in the 2018 timeframe, so that we hit the ground running in 2019 with the full-blown commercial deployments.
Right. So Qualcomm's been around for a while. You've been through a few of these different technologies.
Yes.
The analog days to digital to 3G.
I skipped the analog, but I was there from the early digital days.
You've got a few as well.
Yes.
What is it about this move from 4G to 5G that you think is the biggest challenge? What's different this time around that's going to be the hardest thing to overcome?
So when we did the 3G to 4G transition, the big thing for us back then was we wanted to get one thing and one thing right, and that was mobile broadband. It was about peak rates, very high data rates, larger bandwidth. 20 megahertz back then used to be a large enough bandwidth. And it was the idea of bringing an all IP network. That was the first time we had an all IP cellular network. And that led to mobile broadband explosion with a large number of, it in fact unleashed smartphones into the market and connected tablets. And towards the tail end of 4G, it started expanding into multiple verticals. But in 5G, the difference is, while we are not changing the waveform, fundamentally, OFDMA still remains the case. Right from day one, we are stating that this is not just about mobile broadband. Of course, we're going to significantly increase the mobile broadband capability, but it's not just about mobile broadband. It includes new services that we can imagine that we already see today, things such as massive IoT, which is not about high data rates, but much lower data rates. And these emerging applications, which we simply called as mission critical services. Everyone in the industry talks about it today. But the idea is it's a single network and a single air interface that's capable of all three of these applications, which have very different requirements and very different demands. That is very different compared to what we did in 4G. In 4G, if you think about it, the way we introduced IoT and so on was at a much later stage. So we had to live within the constraints of what LTE was and yet make the appropriate modifications. With 5G, we had a clean sheet of paper, and we started from there and therefore built it so that it's really intended for forward compatibility. Who knows, 5 years from now, we might have a completely new unforeseen application, and we should have an air interface that can still deal with it in a very elegant manner.
Yeah. To sum it up, somebody said to me, I asked them what is 5G. They said everything we didn't put in 4G, and that's what you're describing. It's the network that's going to do all of these things, address all these different markets and use cases.
That's correct. I mean, it is a unifying connectivity fabric, and that's the way we tend to look at it.
Right.
If we really wanted to have everything connected around us, then how would we build it, but not use multiple different air interfaces or multiple networks, but a single network and a single air interface.
Right. Good. So last question for you.
Yeah.
You've been doing this a long time.
Yes.
What keeps you awake at night? What worries you the most, either from an industry perspective or that we're not addressing for 5G?
I think Okay, so from a technology standpoint, I think we'll get it right. I'm not worried about that part. There's a lot of hard work ahead of us, but we've done it in the past, and there's just there's a sense of confidence that, I think we can solve the technological barriers over there. That's actually not a concern. That's the least of the concerns. I think the general, what keeps me up at night, this is at a personal level, is the ecosystem should be ready to embrace the full potential of 5G, the full potential of 5G. And there's a lot over there, and a lot of it deals with not just the technology part of it, but also making the right business model agreements, the right arrangements in place in the entire ecosystem, some of which we from Qualcomm control and some of which we don't control. So for it to take off in the right way, I think the vision needs to be articulated again and again so that people get it and say, oh yeah, you know what, I think I'll be able to use that 5G in a really nice way.
Right.
And it involves a lot of evangelization. So yeah, that's the part that keeps me up at night.
Right. Great. All right, good. Thank you.
All
Good
right,
talking to you
thanks.
today.
Yeah,
Thank you.
thanks.